Good day everyone, we are from Group 5. My name is Eileen and together with my group mate Mushida and King Hui, we have carried out a case study on the topic of a hybrid inventory policy with split delivery under regular and surge demand. This literature has suggested an inventory policy with split delivery. In fact, it is not an ordinary inventory policy, but a hybrid inventory policy under regular and surge demand. So one recent example to explain the importance of hybrid inventory policy would be the happening of the pandemic. As we all know, pandemic has resulted in surge demand in scarce healthcare resources such as sick beds, vaccinations, medications, etc. Thus, it is very important to manage these limited resources and to assure their timely delivery to those who need it the most. Our group has developed 3 problem statements to be the guideline of our study. First, how hybrid inventory models could help in meeting such demand. Second, what is the modeling approach in developing the hybrid inventory model? And lastly, how does a split delivery system enhance an inventory management plan?
Thank you, Eileen. So I'll continue to present about the methodology part. So the article we are using 2 methodology, which is level crossing theory and taboo search based algorithm. So as you can see, this is the LCT. This paper uses level crossing theory in order to derive the distribution of the inventory level at the equilibrium under RQ inventory management policy. So basically, R denotes the reordering point for regular order, Q denotes the regular order quantity, RE denotes the reordering point for emergency order, and QE denotes the order quantity for each emergency order. When the inventory position, which is stock on hand plus stock on order, is equal to or decreases below reorder point R, an order of size Q is placed. The second algorithm starts by building an initial solution PO. If a neighbor is not in the table list, then it is added to this list. If the neighboring solutions are no better than PO, then table search explores other options to improve the quality of solution explored. So the figure included is the procedure of finding an initial feasible policy. Next, we will proceed to case study. We are doing this article because we've seen the challenges faced by healthcare providers or logistic providers in managing their emergency supplies in responding to surge demands. Therefore, we do case study on resource allocation for demand surge mitigation during disaster response. And the discussions and conclusions are, while mutual aid is beneficial in general to maximize resource utilization, it is more beneficial to the smaller counties, especially when resources are being pre-allocated by population proportion. Next case study was a QR inventory replenishment model with 2 delivery modes. The discussion obtained are: observe increasing benefits in our model for increasing values of the mean and variance of the lead time of the less reliable supply mode. Observe that when the supply mode 1 lead time follows a positively skewed probability distribution, the percentage cost reduction due to the dual mode operation is greater compared with the results when we assume that supply mode 1 lead time is uniformly distributed. Next, I will pass to Mushida to present. Thank you.
Assalamualaikum, I am Rushda Binti Nasruddin and I will be presenting about the results and discussion of the case study of hybrid inventory policy of RQ model. These are the defined variables found in the journal. As we know before that, the demand size follows a discrete distribution, and split delivery considers a scenario in which there is a single supplier who replenishes all orders, but the supplier could split the delivery of the orders with multiple shipments. By using split delivery, a service provider can hedge against the risk of possible long lead times when the lead times of the suppliers are stochastic. A split delivery has the potential to reduce the long lead times Using this procedure, a service provider is able to reduce the safety stock needed to maintain high service targets. Note that there are 10 different scenarios generated and used to test the performance of the heuristic. Each scenario consists of a set of model input parameters. As we can see here, the regular demand follows a Poisson process with an arrival rate equals to lambda 1. The surge demand follows a compound Poisson process with an arrival rate of lambda 2, and note that the size of the demand is 1 unit. K1 represents the unit regular order cost, K2 is the fixed emergency cost, H is the unit inventory holding cost per time unit, A is the minimum demand size, B is the maximum demand size, S represents the shortage cost per unit, and QE represents the order quantity for each emergency order. Based on the figures found in the journal, we can see that figure 4 represents the running time of the taboo search and total enumeration. But before that, what is taboo? Taboo search is guided by a taboo list, which is used to avoid visiting some inventory policies that have already been examined. The list keeps a record of the most recent policies visited, as well as the best policies found. The policies of the taboo list are sorted based on the total cost in order to facilitate add, delete, and update operations. The taboo list has a maximum size, hence, when the limit is reached, a new solution is added to the list and one solution is removed. This taboo search procedure is implemented with C++ Visual Studio 2010. So, based on the figure 4, we can see that the computational results indicate that the taboo search procedure provides high-quality solutions. The numerical analysis that, depending on the new scenario, that relative difference between the total enumeration and taboo search heuristics could be between 0.09% and 7.2% as shown in Table 2. Hence, for Figure 7, we can see that the size taboo list versus the total cost. One can see that as the size of taboo list grows, the policy costs decrease. However, the decrease in cost is very small when the size of the taboo list is larger than 30. If the size of the taboo list is too big, the additional computational time is required to add and delete and update the list. Thus, the search procedure spends a good portion of the computational time updating the taboo list instead of exploring the solution space, as we can see in Figure 4. And for Table 2 is based on the summary of results from the taboo search heuristics. The performance of the hybrid inventory policy with split delivery is what we are finding for in this journal. As we can see, numerical results show that the hybrid inventory policy with split delivery outperforms hybrid inventory policy with standard delivery for relative low shortage and holding cost. But hybrid inventory policies with split delivery tends to be expensive with both shortage and holding costs are high. The comparison of hybrid inventory policy and split and standard delivery is that based on Table 3, the journal investigated the benefit of using the hybrid inventory model over the basic inventory policy without emergency orders. They showed that the emergency order point RE is sensitive to unit shortage cost as and increases as unit shortage cost S grows up. The numerical analysis indicates that considerable cost savings are obtained from split delivery depending on various instances. Thank you.
Finally, we have come to the conclusion. So first we learned that split delivery is a technique of splitting the delivery using multiple shipments in order to reduce the safety stock required to maintain high service levels. Second, a high taboo search-based heuristics is developed and it finds high-quality solutions in a shorter time than the explicit enumeration. Third, the level crossing theory is used to formulate and calculate the equilibrium equations under a given inventory policy using the ordering points and order quantities. Lastly, numerical results generated show that hybrid inventory policy with split delivery actually saves 3.5 to 42.1% of the total cost. So some future work could be done to the research are highlighted also. Now first, Research direction could be extended to the model to a multiple location case. Second, this hybrid inventory model could be extended to perishable products with a fixed or variable shelf life. Third, the optimization approach could be extended by developing exact solution algorithms which find optimal inventory policies.